There's a question that keeps physicists awake at night, a question so fundamental that it undermines everything we think we know about reality. Why are there laws of nature at all? Not what are the laws? We've got equations for that. Not how do the laws work? Experiments answer that. But why do laws exist in the first place? Why does the universe follow rules instead of being complete chaos? Why is reality ordered, predictable, mathematical, comprehensible? Michio Kaku has confronted this question throughout his career, and he's reached a conclusion that might surprise many who see him as a pure rationalist and scientist. The existence of natural laws, their specific character, and their mathematical elegance all point toward what he calls God. Not necessarily the God of any particular religion, but a cosmic intelligence that makes sense of why reality has laws at all. This is philosophy at its deepest, metaphysics at the boundary, where science meets ultimate questions. And Kaku argues that science, by revealing the extraordinary nature of physical laws, has made the God hypothesis more compelling, not less. The more we understand about how finely tuned and elegant the laws are, the more difficult it becomes to dismiss them as cosmic accidents. Consider what laws of nature actually are. They're statements about how reality must behave. Not how it does behave in this instance or that instance, but how it must behave always and everywhere. Drop an apple on Earth, it falls. Drop an apple on Mars, it falls. Drop an apple in a galaxy 13 billion light years away, it falls. Gravity works the same everywhere, always. The speed of light is constant. Energy is conserved, entropy increases. These aren't suggestions. They're ironclad requirements that reality never violates. But why? Who or what enforces these laws? If you break a human law, police intervene. If you break a physical law, what happens? Actually, you can't break a physical law. It's not possible. The laws aren't restrictions imposed on reality from outside. They appear to be constitutive of reality itself. The universe doesn't follow the laws. The universe is the laws, expressing themselves through matter, energy, space, and time. This is profoundly strange when you think about it. Kaku points out that scientific materialism, the view that nothing exists except physical matter following physical laws, has a fatal problem. It can explain everything within the system, how particles interact, how forces work, how complexity emerges, but it cannot explain the system itself. Why these laws? Why laws at all? Some scientists shrug and say that's just how it is, a brute fact requiring no explanation. But Kaku finds this intellectually unsatisfying. Science is built on the principle that everything has an explanation, that we can always ask why and dig deeper. To suddenly declare that the most fundamental question of all, why do laws of nature exist, is off limits or meaningless, seems like giving up at the exact moment when things get interesting. The alternative is to recognize that laws require a lawgiver, not in the sense of a bearded legislator in the sky, but in the sense that order requires an ordering principle, that mathematical structure requires a mathematical source. Kaku suggests that God, understood as cosmic intelligence or universal mind, provides the necessary grounding for why laws exist and why they have the character they do. Think about what the laws of nature accomplish. They make the universe comprehensible. They ensure consistency across space and time. They permit complexity to emerge from simplicity. They allow for chemistry, biology, consciousness, intelligence. A universe without laws or with different laws would be incomprehensibly chaotic or boringly simple. The actual laws we have sit in a sweet spot, complex enough to generate richness, but simple enough to be understandable. This looks like intention. It looks like the laws were chosen or at least selected from possibilities to accomplish something. And what they accomplish is the generation of complexity, consciousness, and the ability for the universe to know itself. That's not a scientifically provable claim, Kaku admits, but it's a reasonable inference from the data we have. The specificity of the laws supports this view. Physics could work with 3 spatial dimensions, or 4, or 2. We happen to have 3. Why? It turns out 3 dimensions is the only number that permits stable orbits and complex chemistry. 2 dimensions would be too constrained. 4 or more would make orbits unstable. 3 is just right. A Goldilocks situation that seems almost designed. The strength of forces could be anything. The electromagnetic force could be stronger or weaker relative to gravity. The strong nuclear force could have different coupling constants. But the actual values permit atomic nuclei to be stable, allow stars to burn for billions of years, and enable the chemistry necessary for life. Change the values even slightly, and you get a universe without complexity. Kaku emphasizes that this isn't an argument from ignorance, a god of the gaps, where we invoke divine explanation for things we don't understand. This is an argument from what we do understand. We understand the laws extremely well. We can write them down, test them, use them to build technology, and the more we understand them, the more remarkable they appear. The laws show characteristics we associate with intelligence. They're elegant, achieving maximum explanatory power with minimum complexity. They're purposeful, working together to generate complexity rather than preventing it. They're comprehensible, structured in ways that conscious minds can grasp. These aren't characteristics we'd expect from random, purposeless processes. Compare the laws of physics to other possible systems of rules. Computer programmers write code to accomplish specific goals. Good code is elegant, efficient, well-structured. Bad code is messy, redundant, fragile. The laws of physics look like really good code. They're the kind of rules you'd write if you were a master programmer trying to create a universe that could support complexity and consciousness. The mathematical structure of the laws reinforces this impression. Mathematics isn't arbitrary. Certain mathematical structures have inherent beauty and power. The laws of physics consistently use the most elegant mathematical formulations. Einstein's field equations can be written in multiple ways, but the most compact and beautiful form is the one that works. Maxwell's equations have a symmetry and elegance that lesser formulations lack. Kaku notes that physicists use beauty as a guide to truth. When developing new theories, they look for mathematical elegance. Ugly theories, even if they initially seem to work, usually turn out to be wrong or incomplete. Beautiful theories, even when they seem wild or counterintuitive, often turn out to be right. The Dirac equation predicted antimatter because the mathematics was too beautiful not to be true. This suggests that there's an aesthetic principle operating in nature, a preference for beauty over ugliness, elegance over complication. But aesthetic principles require an aesthetic sense. They require something that can appreciate and choose beauty. In other words, they require a mind. Kaku draws on Einstein's conception of God here. Einstein didn't believe in a personal God who intervenes in human affairs, but he believed deeply in what he called Spinoza's God, the God revealed through the orderly harmony of nature. Einstein wrote that he wanted to know God's thoughts and that everything else was just details. For Einstein, God was the mathematical order underlying reality. Kaku embraces this conception and extends it. If God is the mathematical order, then studying physics is studying the mind of God. The laws of nature are God's thoughts, eternally true, expressing themselves through physical phenomena. Scientists aren't engaged in a secular, godless pursuit. They're engaged in natural theology, reading the book of nature to understand its author. This resolves the apparent conflict between science and religion. They're not competing explanations for the same phenomena. Science explains how things work within the system of natural laws. Religion, or at least philosophical theology, explains why the system exists and has the character it does. Science describes the mechanisms. Theology points to the source of those mechanisms. The laws of nature also show a kind of necessity that demands explanation. 2 plus 2 must equal 4. It cannot equal 5. This is mathematical necessity. Similarly, given the laws of physics and initial conditions, subsequent states of the universe are determined, at least in classical physics. There's a logical necessity built into how reality unfolds. But where does this necessity come from? In mathematics, we can trace necessity back to axioms and definitions. In logic, we can trace it to logical principles. But in physics, the necessity seems to be rock-bottom fundamental. The laws simply are, and everything else follows necessarily from them. Kaku suggests that this necessity reflects the nature of the source. If God is mathematical intelligence, perfect rationality, then the laws expressing this intelligence would have a necessary character. They couldn't be otherwise because they're expressions of a perfect mind, thinking perfect thoughts. The logical necessity we observe in nature mirrors the logical nature of the divine intellect. This might sound abstract and impersonal, lacking the warmth of traditional religious conceptions of God. But Kaku argues it's actually more profound. A God who is the ground of natural law is literally everywhere and in everything, not just watching from outside, but constituting reality from within. Every atom, every force, every event is an expression of divine nature. The pantheistic or panentheistic flavor of this conception has deep roots in both Eastern and Western philosophy. The Tao of Taoism, the Brahman of Hinduism, the Logos of ancient Greek philosophy, all describe ultimate reality in similar terms. A rational principle, an ordering intelligence, a cosmic mind that structures existence while being immanent within it. Modern physics adds mathematical precision to these ancient insights. We can now specify exactly what the laws are, test them experimentally, and use them to manipulate nature. But the fundamental mystery remains. Why these laws? Why laws at all? And the answer that makes the most sense to Kaku is that laws exist because reality is grounded in intelligence, in a cosmic mind that thinks mathematically. The fine-tuning of universal constants provides additional support for this view. The cosmological constant, which drives the accelerating expansion of the universe, has a value so precisely calibrated that changing it by 1 part in 10 to the 120th power would make the universe either collapse immediately or fly apart too fast for galaxies to form. That's precision of 1 part in a trillion. No selection process, no random chance mechanism could produce that level of precision. It's like throwing a dart at a target the size of the observable universe and hitting a bullseye the size of a single proton. The only plausible explanation is that the value was set deliberately, chosen to permit the universe to exist in a form capable of complexity and life. Critics argue that the multiverse explains fine-tuning without invoking God. If infinite universes exist with all possible constants, we obviously find ourselves in one fine-tuned for life. But Kaku points out this just pushes the question back. Why does a multiverse exist? What are the laws governing the multiverse? If the multiverse generates universes with different constants, what mechanism does this and why? The multiverse hypothesis doesn't eliminate the need for laws, it multiplies them. Now you need meta-laws governing how universes are created and how their constants are assigned. And those meta-laws would themselves require explanation. You end up with an infinite regress unless you ground it in something that doesn't require further explanation, something necessary rather than contingent. And the most coherent candidate for that necessary ground is cosmic intelligence. Kaku also addresses the problem of evil, which troubles theological explanations. If God is the source of natural laws, and natural laws permit suffering, disease, death, isn't God responsible for evil? This is one of the oldest philosophical problems, the theodicy question of how to reconcile divine goodness with worldly suffering. Kaku's response is that the God he's describing isn't concerned with human moral categories. This isn't a God who micromanages individual lives or cares about human ethical choices. This is a God whose thoughts are the laws of nature, playing out with complete impartiality. Earthquakes and tsunamis aren't divine punishment. They're consequences of plate tectonics and fluid dynamics, following laws that make Earth habitable in the first place. The trade-off is inherent. Laws that permit complexity and life also permit entropy and death. You can't have biological evolution without death. You can't have geological activity without earthquakes. You can't have chemistry without thermodynamics, which includes decay and dissolution. The package deal of natural laws brings both creation and destruction. This doesn't make suffering less real or painful, but it situates it in a different context. Suffering isn't evidence against cosmic intelligence. It's an inevitable consequence of laws that make any existence possible at all. A universe with laws that prevent all suffering would be a universe without change, without complexity, without life, without anything interesting happening. Some find this cold comfort, but Kaku notes it's intellectually honest. The problem of evil is genuine, But it's not a decisive argument against the existence of an ordering intelligence behind natural law. It's an argument against specific conceptions of God as omnipotent and perfectly benevolent in human moral terms. But those aren't the only possible conceptions. The predictive power of natural laws also suggests intelligence. The laws don't just describe what happens, they allow us to predict what will happen. Newton's laws let you calculate where a planet will be years in advance. Quantum mechanics lets you predict the properties of materials that have never been synthesized. General relativity predicted gravitational waves a century before we detected them. This predictive power means the laws contain information about the future, not just the present. They're not just constraints on what can happen now. They're algorithms that determine how now evolves into later. That's a remarkable feature requiring explanation. Why should the present state of the universe contain, encoded within it, information about all future states? If reality were truly random, truly purposeless, there would be no reason for this predictive power. Each moment could be disconnected from the next. But instead, reality has a narrative structure, a logical flow from past through present to future, all governed by timeless laws. This temporal coherence, this story-like quality to existence, suggests authorship. Kaku points to quantum mechanics as particularly revealing. The quantum world is probabilistic, not deterministic. You can't predict exactly where an electron will be, only the probability of finding it in various locations. This seems to undermine the idea of law-governed necessity. If quantum mechanics introduces true randomness, then the universe isn't fully determined by laws. But quantum probabilities aren't truly random in the sense of being lawless. They follow precise mathematical rules. The Schrödinger equation governs how probability waves evolve. The Born rule determines how to calculate probabilities from wave functions. Heisenberg's uncertainty principle sets absolute limits on what can be known. Even quantum randomness obeys laws. This suggests that laws operate at a deeper level than classical intuition suggests. They don't determine specific outcomes, but they determine the space of possibilities and the probabilities within that space. God, in this view, doesn't micromanage every quantum event, but God sets the rules that govern how quantum events unfold statistically. The role of observation in quantum mechanics adds another layer. Quantum systems exist in superposition until observed, then collapse to definite states. This seems to give consciousness a fundamental role in actualizing reality. If consciousness affects physical outcomes at the quantum level, then mind and matter aren't as separate as classical physics suggested. Kaku speculates that this might reveal something deep about the relationship between cosmic intelligence and physical reality. If the universe requires observers to actualize definite states, and if consciousness is ultimately rooted in cosmic intelligence, then physical reality might be a process of the universe observing itself, God knowing God's self through countless conscious perspectives. This connects to the participatory anthropic principle proposed by physicist John Wheeler. The universe doesn't just happen to be compatible with observers. Observers are necessary for the universe to exist in definite form. We're not passive witnesses to an objective reality independent of us. We're active participants in bringing reality into being through observation. If this sounds mystical, Kaku notes that it's grounded in rigorous physics and mathematics. The role of observation in quantum mechanics is experimentally verified countless times daily in laboratories worldwide. What remains unclear is why observation matters, what consciousness really is, and how it relates to the mathematical structure of quantum theory. But that it matters is beyond dispute. The convergence of physics and consciousness suggests they're not separate magisteria, but interconnected aspects of one reality. And if that's true, then the cosmic intelligence grounding natural law and the consciousness experiencing those laws might be fundamentally the same thing, viewed from different perspectives. The subject and object of knowledge ultimately united. Kaku acknowledges this pushes beyond what science can strictly prove, but he argues it's where the evidence points. The laws of nature are too elegant, too finely tuned, too comprehensible, too purposeful to be cosmic accidents. They show every sign of having been chosen or shaped by intelligence. And the most parsimonious explanation, for why laws exist and have the character they do is that reality is grounded in mind, in what religious traditions call God and philosophers call absolute or ultimate reality. This doesn't prove God's existence in any logical sense. Metaphysical claims, by definition, transcend empirical verification. But it makes God reasonable, perhaps even probable, given what physics reveals about the nature of law, order, and intelligibility in the cosmos. It shifts God from being an optional add-on, something you believe through faith alone, to being a rational inference from the existence and character of natural law. For Kaku, pursuing physics is ultimately a spiritual journey, though he might not use that exact language. Every equation solved, every experiment conducted, every insight gained, is a step toward understanding the mind behind the cosmos. The laws of nature are love letters from the divine, written in the language of mathematics, waiting for conscious beings to read and comprehend them. Whether this intelligence is personal or impersonal, transcendent or immanent, unitary or something beyond those categories, remains mysterious. The laws reveal that intelligence exists and structures reality, but they don't reveal the full nature of that intelligence. We see the thoughts, the mathematical patterns, but the thinker remains largely hidden, knowable only through the order and beauty of creation. Yet even this limited knowledge transforms how we relate to existence. If natural law expresses divine intelligence, then everything is sacred. Every atom, every force, every phenomenon is a manifestation of the ultimate. Science becomes not a secular alternative to religion, but a path toward the divine, a way of knowing God through understanding God's thoughts as expressed in the structure of reality. This vision reconciles the scientific and religious impulses that have seemed at war in modern culture. It shows them as complementary rather than contradictory. Science reveals the how, the mechanisms by which reality operates. Religion and philosophy point to the why, the ground and purpose of those mechanisms. Together they provide a more complete picture than either alone. Kaku's conclusion, arrived at through decades of theoretical physics at the highest level, is that God makes sense of the laws of nature, because without God, or at least without cosmic intelligence as the ground of being, the existence of laws becomes inexplicable. Laws require a source. Order requires an ordering principle. Mathematical beauty requires an aesthetic sense. Comprehensibility requires a rational foundation. The alternative is to accept that laws are brute facts, requiring no explanation, that order emerged from chaos for no reason, that mathematical beauty is projected by human minds onto an indifferent reality. But these alternatives seem less intellectually satisfying than acknowledging what the evidence suggests, that reality is grounded in intelligence, that the cosmos is ultimately mental or informational rather than material, and that what religious traditions have called God is the best name we have for this ground of all existence. The laws of nature, in Kaku's view, are the fingerprints of God, the signature of cosmic intelligence written into the fabric of reality. And the task of physics is to read that signature, to understand those thoughts, to know the mind that thinks the universe into being through the eternal mathematics of natural law. That's why God makes sense, because without God, nothing else does.